Okay, Stoic and Faraday's law. We can calculate the number of electrons that pass through a cell, and that way we can determine the mass of the substances. So stoichiometry always reduces down to a ratio of moles. Well, in this way it's a little hard to figure out moles because we don't have a super big reaction happening, but we can calculate it using electricity, time, and a constant. So Michael Faraday looks at the relationship between electrical current and electrochemical changes. So change in mass or change in concentration that happen at each of those electrodes. He said that the mass of an element produced or consumed is directly proportional, here's some theory questions, to the current and the time the cell operates. It's known as Faraday's law. And so you need to memorize this beautiful formula, because our chem data books do not give you formulas. Okay? I is the current measured in amps, time is in seconds, and Faraday's law is C per mole. We're probably looking at coulombs. Here's some physics for you. Faraday's law applies to both voltaic and electrolytic cells. Make sure that you are in amps and not milliamps or megaamps. Make sure you're in seconds and not minutes or hours or days. In order for us to use Faraday's law, we actually have to be able to see the electrons. Half reactions are the only reactions that use electrons. Okay? So all cell stoichiometry are based on half reactions and not the balanced redox reaction. Because if you're balancing your redox reaction, you're canceling out your electrons. So what is the mass of copper deposited at the cathode of a copper electrorefining cell operating at 12 amps for 40 minutes? So cathode is what reaction? Reduction. This is why it's really important for you to remember cathode is reduction and anode is oxidation, because we have no picture. Okay? So if it's a reduction and we're talking about copper, what's happening in my reaction?
Gaining electrons.
It's gaining electrons. Okay? So those are things you have to understand. Loss of electrons is oxidation, gain of electrons is reduction. Cathode is reduction, anode is oxidation. Those pieces are what you need to be able to extract and decode out of a question. Okay? So now that I have this, my information that I have 2 electrons, I have the current, I have the time, and I am looking for what is the mass of copper deposited. So I'm looking for this. Set up the exact same way we do any other stoichiometry question. We put the information we have underneath whatever it is in our reaction. Okay? What's something that we need to do before we do anything else? Convert to time. Okay, 2400 seconds. So just like in any other stoichiometry question, we need moles of what we have. And the way that we do it in a question like this, N of electrons equals IT over Faraday's constant. So 12 amps times 2400 seconds divided by 9.65 times 10 to the 4 coulombs per mole. We get what for a value?
I got 0.298.
A coulomb, if we were to go back and do a unit analysis on a coulomb, we're going to see that current and time are part of it, and all we're left with is mole. Okay? So now we have, this is the moles of electrons. As always, we now look at mole ratio. So we have 0.2984 moles of electrons. How many electrons do we have in the reaction? 2. And how many moles of copper do we have? 1. And now that we have moles of copper, how do we get to grams of copper? Molar mass. And the molar mass of copper is?
63.55.
And we get what for mass? Get an answer, Sophia? And when we go back to the question and we look at significant figures, 3 says 9.48 grams of copper. Is deposited. Okay? Easy peasy. No? In the chlor-alkali industry, so this is pulp and paper. We'll see this used quite a bit. Large quantities of chlorine are produced using an electrolytic process that is described below by the following chemical equation. So we get sodium chloride plus water gives us sodium hydroxide, chlorine as a gas, and hydrogen as a gas. Note that this is the balanced redox reaction. If 500 grams of chlorine needs to be produced in 24 hours, what is the required current? So this is, if it's asking us for current, we know that we require electrons, which means that we need a half reaction. Okay? And it's asking us specifically about chlorine. So when we look at our oxidation numbers to figure out which one is being reduced and which one is being oxidized, let's focus on chlorine. So it's going from a chloride ion to chlorine as a gas. So what do I need to put here?
1 electron on the right.
How many chlorines do we have here?
2.
Or quarks? How many do we have here?
1.
So how many electrons do I need? Or wrong side?
Yeah, okay.
Okay, I was confused.
No, I was very.
I was just testing her. Okay. What kind of reaction is this?
Oxidation.
Oxidation.
Reducing agent.
It's oxidation because it's a loss of electrons. Right? You're going from -1 to 0. It's a loss of electrons. Okay, let's fill in the information that we know. We have 500 grams of chlorine is produced in 24 hours. What is our current? Okay, any other pieces of information that we're going to need to help us out?
You can write the constant down.
We could write the constant in. Any other pieces of information?
Molar mass.
Molar mass of chlorine. Yeah, don't say 35.45 because there's 2 of them. Okay? So, stoichiometry always starts out with what you have. We have this information. We want this information. Okay? So we're going to start with our 500 grams of Cl2. I'm going to do it in one line. If you see it easier in a bunch of steps, feel free to do it that way. There's nothing wrong with it. Okay? How many moles of chlorine gas do we have in the equation? 1. How many moles of electrons do we have? 2. So, 2 moles of electrons is where I want to end up, and what do I end up with for a value? Okay, so now that I'm at moles of electrons, now I can figure out the required current. There's something that we need to focus on before we go there, and what is that?
Changing hours to seconds.
Change hours to seconds. So if I have 24 hours, in 1 hour there's 3,600 seconds. So I get what for a value?
86,400.
So N electrons equals I/T over F. It's asking us what current is required. When I rearrange the equation to isolate for I. do I get for our current value? Did you already solve it, Cameron?
Yeah, 15.8.
Okay. There are 2 practice questions that I'll let you work on, and then there are 4 problems, and I'll put them up on the board for you to work on.